What's up, guys? Good guy here. Today we're going to be doing some Calculus 3, third semester calculus in American school systems. Yeah, so let's get started. Today we're going to be focusing on finding the area of a surface going over like a defined region. And although this question doesn't explicitly say we're finding the volume, that's what we're doing, because when you take the double integral with respect to the area, you're really just taking the volume. Alright, so let's do this, baby. So remember, a lot of stuff. So our surface is f of xy. Our surface is just the integrand, so f of xy, and this is just equal to z. F of xy is equal to 8x ln y. And let's define our region first. So our region is bounded by x equals 0, y equals 1, y equals x, and y equals 7. So we get this trapezoid as shown. Yeah, awesome. So this region right here, D, is what our surface is going over, and we need to find the volume underneath the surface and above the positive x, y, yeah, above the positive x-axis. I mean, above the positive z plane. I don't even know what I'm trying to say. So, what do? Well, we do take the double integral with respect to the domain, or yeah, with respect to the domain, I guess you could call it. I just call it the region D, and with respect to area. Well, what is dA respect to area? What does that mean? Well, it's either dy dx or dx dy. All this means is that we're finding the cross section of either x or y, and then we're moving it through the opposite variable. So we take the cross section of y and we move it through x, and that gives us our volume. I hope that makes sense. I don't think it really does. You need to do some reading, watch some videos on it. That will really help. But let's differentiate with respect to x first, because I've already done this problem and I know it's pretty easy to differentiate with respect to x even if you don't have a calculator. Well, you do need a calculator for this problem, a basic one, but if you don't have like an integral calculator, this differentiating respect to x first is, in my opinion, a little bit easier. So what we do now is we define the boundaries for x and y. Well, x is bounded by x equals 0 and x equals 7. Y is bounded by y equals 7 and y equals 1. But if we differentiate with respect to these boundaries, we're differentiating a square or a rectangle. I don't know if that's a square or not. But yeah, what do we do? We have to take into account this y equals x going through it, cutting it in half almost. Well, what we do now is we decide which variable we're going to differentiate to, which variable we're going to integrate with respect to first. Because if we integrate with respect to y, we're going to have our boundary for y be y equals x and y equals 7, so we're going like this. But if we're differentiating with respect to x, we're going from x equals 0 to this, to x equals y. So I hope that makes sense. Since we're differentiating with respect to x first, we're going to use x equals y and x equals 0 as our boundaries, and our boundaries for y are y equals 1 and y equals 7. So we're going like this. Yeah, we're going like this, and then we're moving it through y. I don't even know how to explain that crap. It's pretty dang hard to wrap your head around it unless you're just not stupid. So 8x ln y dx dy, and our boundaries for y are 1 to 7. So then this becomes, well, first, how do we differentiate, or God, I gotta stop saying that. How do we integrate with respect to x when there's a y in there? Well, we just treat the y as a constant, so this can be rewritten as, and don't get scared by the double integral. All you gotta do is ignore this until you're done with the first one. So this first integral can be rewritten as ln y on the outside times 0x integrate the integral from 0 to x of x 8x dx dy, and then this is equal to x squared fourth times ln y, and this is evaluated from 0 to x, and then this becomes, oh sorry, oh my gosh guys, I think I messed up. We're not going from 0 to x because x equals 0, but x does not equal x, because if x equaled x, then it'd just be like a straight line, or just be this whole thing. No, x equals y. X equals y. Okay? So we're evaluating this from 0 to y. Sorry about that. That would have been bad. So I hope, oh crap, I hope people didn't do the problem and be like, oh my gosh, I got this wrong. Nah, that sucks so bad. I probably should put a disclaimer. Times ln y minus 0, because when you plug in 0, it's all that crap. So now we have the integral from 1 to 7 of 4y squared times ln y dy. And then this is equal to, if you have a calculator, this is where you're like, hell yes. If you don't, this is where like, how the hell do I integrate this? I'll integrate this after I plug this into my calculator. If you want to know, it'd be good for you. If you already know, then you can probably just take this answer. It's equal to 737.93. Yep. Alright. And remember, we're differentiating from 1 to 7 as shown on this graph. If you want to know how to integrate, that's what I'll do that now. So 8x or 8y squared ln y over 2 integral from 1 to 7, and then dy. So this is equal to, what is this equal to? So now we gotta set up some crap. So this, we can rewrite this as 8 over 2 on the outside, which is 4. I don't know why I'm doing this crap. 4. Yeah, okay. Okay. So 4 times integral from 0 to 7 of y squared ln y. Now, a lot of you will recognize the pattern here immediately. If you don't, that's completely fine. But I'll show you. It's integration by parts. And remember, the integration by parts is u dv, the integral of u dv is equal to u v minus the integral from d u v. So our u here in this case is equal to ln y, because it goes from being a natural log to the normal number stuff. You know, it goes to 1 over x. And our dv is y squared, and our v is equal to y squared, and then y to the cubed over 3. That's our v. dv is equal to y squared. V is equal to y cubed over 3. So now we have this is equal to 4 times all of it. 4 times ln y times y cubed over 3 minus the integral of 1 over y times y cubed over 3, and this cancels into 2, and now we have y squared over 3, which is, and this integral is equal to y cubed over 9, and it's negative, and then this all becomes 4 y cubed over 3 times ln y minus 4y cubed over 9. And then when we evaluate this from 1 to 7, and this is where you need just like a normal calculator that can do log naturals, natural logs. We get, well, I already know what we get. I'll just, yeah. The things I do. Alright, so we have, I'm gonna plug in my calculator real quick. This is a good way to double check too, I guess. Even though I already know what the right answer is, it's just a good way to double check I did everything right. In my integration by hand. Alright, that should, yeah, unless it did some run. Okay, and then, so plugging in 7 gives us 737.485 minus, and then when we plug in 1, log natural of 1 is just 0. So this we can ignore this, minus 4 over 9. So 737 minus 4 over 9 is equal to 737.041. And that should be what we got for the integral, and that is not what we got for the integral. What did I do wrong? What did I do wrong? What? Oh my gosh, guys, thanks for watching.